Hello. In this tutorial, I'm going to show how to create a NMOS layout in Cadence Virtuoso platform. Um, before creating the layout, we have to know that the DRM file for this PDK. So in here, I'm going to work in 45 nanometer PDK. So uh, here is my DRM file. For your PDK, you can see the DRM file in docs folder, any kinds of different kinds of folder maybe happen. So you can find the DRM file. In this DRM file, here is the all kinds of the process specification for this 45 nanometer tape. Like in active rule, here is the information for the minimum active area. This is basically oxide area. This is 0.05. For the poly rules, here you can see the uh, poly rules, and is the contact rules, and metal one rules, and all the information in associated with this PDK. So this DRM is uh, mainly 109 ways. So first of all, we have to understand which types of layer are in NMOS. So basically, here is an oxide layer, and the NIM and implant layer for the implantation, and the contact, a poly layer, a metal layer, um, or a dummy layer. We have to create all this separately. So first of all, let's do it. So here I summarize the note and notes, and summarize all the requires rules from this DRM. Okay. Okay. I launch a new layer Excel. First of all, what we do, we have to create a contact. So there is no layer. I need to contact layer. So contact draw. To draw, you can use R. So what is the rule associated with this contact? Let's see. The minimum, maximum, and minimum contact width or length is 0.06 micrometer. So we have to set the rules. If it is fixed, then it's okay. To set, you can easily press K, and here is in 14. So what we have to do, we have to make it 0.06. You can use this measurement and make it 0.06, or another way, that select, then press Q, and with what we have to make it 0.06, also 0.06. Okay, then we need another contact. Then we need a poly. So let's get a poly. You make poly. To draw a poly, you can use P, or you can use R to draw a poly. We can set A. So what is the minimum contact on active area gate spacing? That's mean poly to contact spacing is 0.05. Here is another function, DRD identify on. Here you can here if you turn on this option or tools, you can hear that uh, you can hear the the pop-up of this DRM design rules. That's called minimum spacing. So what is say the minimum is 0.05. Okay, that's 0.05. Okay, and is another rule. There's the minimum poly width. Poly width we have to say. Okay, poly width. Minimum poly width is 0.045. 0.045. Okay, then I'm okay, and then after that we have to minimum active area to contact enclosure is 0.03. So we have to create a active area. That's mean we have to create an oxide layer. That oxide. We don't need DRD because it's so many clumsy. Okay, what it said minimum 0.03. That's good. Then I have to feed it. Okay, well, to check the DRD we can also launch the DRC. In current situation, if there has any error or not, we can check it. Okay, ignore the metal one area, ignore that. Oxide, polysilicon, medium area. Okay, okay, let's create first, then okay, after that what do we have to do? Then poly, then oxide to poly 0.01. Zero point 0.1. What is this? N channel gate extension. I have the gate extension 0.1. Okay, and then N implant, poly width is okay, active area, okay, all this okay. And now the rule is the N implant, so we have to create an implant layer. This is a name layer. Okay, so minimum active area to enclosure is 0.07. Okay, so after that the gate end cap enclosure, so we have to draw another name layer. So 0.1. Okay, okay, and then The another layer, the last layer, sorry, the not last layer, we have to another layer, that's basically the, okay, then the metal, we have to make a metal layer. So metal 1, metal 1. So if I draw this metal 1 layer, with is 0.06, okay, then there is another layer, then the last layer, which is the dummy layer. So okay, then this edge is enclosure 0.01. So this is basically the, the NMOS transistor layout. For if you want to check, let's see, if I create an instance from the 45 nanometer, this is from the PDK, it's from the PDK library. Okay, can see the oxide. And I have to assign the drain and source. This is the another issue, but in layer purpose, here is the oxide layer, also the oxide layer. And see, this is 0.14, this is 0.14, and this is 0.045, this is the 0.045, and then the poly, then the limb, the contact, metal one, the PW dummy. All the layer is here. Okay, for the PMOS, there is only another, only the two difference. This here is the, for there is no PW dummy. For N implant, here you have to make it the PIM player, and here will be another NOL, and then it's okay. Okay, if I make for the PMOS, let's make it for PMOS. Just make it copy for the PMOS. Here will be another extra layer. This is change the layer, change it to PIM. Or PIM drawing, or make it NOL. Okay, this is for the PMOS. This for the NMOS. This for the PMOS. If you are going to use it for the further purpose, then make it a cell. First select all the layer, edit, hierarchy, then make cell. I have to make it a PMOS. Okay, here is here you can see this is like a cell. If I delete it, instance, there is log tutorial PMOS. Okay, you can work, you can also using this MOSFET for the layout. Like if you need a PMOS, then you can use it. Okay, so thank you everyone for this tutorial. uh,